time. Welcome to episode 12. Well, after messing with this for way too long, I am ready to drill. I'll probably do that this evening, maybe later this afternoon. So these are some drill jigs. They look kind of cluttery, all clamped in place. I've got some photographs I'll put up. Here's the short version. Actually, it's the long version. So these drill jigs I have right here are exactly what I had in mind when I first thought about how I was going to drill these holes in the forward spar so that they match up with this spar carry through. Now the manual, it has you take a bunch of very careful measurements from the center of that hole to the center of this hole and get that dimension, and then they want you to dimension it from an imaginary center point here. And then once the tube is covering it up, they want you to lay those dimensions out on top of the tube and drill through there. They have you pilot it and then open it up with a file and make sure it's still centered, and then open it up some more and finally ream it. And that sounds like a whole lot of areas where I could incorporate error. And being a recovering tool designer, I spent about 7 years doing aerospace tools. This type of drill jig makes a lot of sense to me. And I alluded in the last video that I was going to make a strap duplicator. That's not what this is. I have another clip I'll throw in here showing the strap duplicator and why I decided it wouldn't work. So I'm going to run that all by itself, and then I'll get back to this. Mentioned in the last episode how I was going to make a strap duplicator. I'm going to be clear right up front, this is not one. This is kind of based on the same idea. Ignore this hole right here. But I abandoned it pretty quickly. And it was because mine isn't coming out very well, and I took this to the airport to see if I made a better one, how well it was going to work. And at that point, I had already decided to go back with the drill jig, which is the basis of episode 12, and drill these holes out. But just so everybody knows what one is, because they do come in handy. Strap duplicators gets the name strap from the length like that, I'm assuming. They're usually steel. They're almost like hacksaw blade strength. They're riveted very securely at the bottom end. And then they have, so this is just two, I tried to make them anyway, concentric holes. This would be a number 30 pilot on this side, and this was the reamed hole at 5/16, 0.3125. And so what a real strap duplicator is, it has a pressed in fitting right here with a stud, which is the size of a hole which you're trying to copy. So quick side trip, here's where they normally get used in real life. Don't have my Sharpie pen with me, but if you imagine a pair of overlapping airplane skins, and this one having a row of holes in it, which I need to duplicate into this outer skin. Ideally, any mechanic would back drill through the other side, but sometimes that structure is blind. It's not accessible by a human, so you got to find some way to pick up each of those holes. And so the strap duplicator, if it had that pin, kind of a stud sticking out on this side, you would lift the skin, you drop it into that hole, and it's therefore the hole location is known. And then on this side, there'd be a drill bushing, which is also attached to this, and that's where it gets kind of tricky. There's some kind of pressed in to sheet metal, be like a PEM nut, or maybe it's soldered on or something that I can't achieve. For the purpose of this job, I didn't need that anyway. I really just I was hoping to pull the spar off, run a pin up through just the same way I'm going to describe for the regular fixture, 5/16 diameter, and then locate this, and then I was going to clamp this with a bunch of tape and zip ties, etc., onto the spar carry through, slide the spar on, and then I could at least pilot out this hole. And then my intention was to blow it out to the 19/64 and then ream it and so forth. Couple limitations with that. First of all, I didn't have a whole lot of faith that when I clamped this to the spar carry through, that it was going to stay absolutely firm. In other words, once I got the spar on top of here and I started drilling, what if it moves a little bit? Well, then I would have to take the wings off again, try and reestablish this. And even if I did have some kind of a stud on here which dropped in, the nature of the aluminum scrap strip that I'm using right here, it's a little too squirmy, and it led me to not have a whole lot of confidence the idea was going to work. I would also have to put the hammer some curvature into this surface right here to match the inside of the spar. Otherwise it was going to take up too much room. Or alternately, I would have to make it so much thinner that, again, it would be super flexible and therefore have even less likelihood to maintain concentricity here. So this idea, I abandoned that and went back to the other fixture. So it was in the last video, somebody made a comment that said, hey, go look at Nick's, can't pronounce his last name, sorry, video. He went to the Kitfox factory where Brandon drilled up the wing. It showed they use a laser level or whatever to align the rear spars, and then they have this drill jig which looks a lot more like what I've got here. So it's just a V-block which centers the tube, and then it has actually a very long drill bushing which helps keep it piloted in the correct direction. And it looks like they just do a one-step, blow the hole through, and done. Pretty awesome, especially if you're practiced up, and I'm not. So the strap duplicator, basically DOA, and then having watched Brandon's factory fixture where they drill this in one shot, led me back to this basic design right here. This was easy for me to fabricate. I put a little bit of money into these bushings, which is why I'm gonna offer these fixtures up to other people that are doing slow build wings. Hopefully I can keep them in rotation and they can pay off in the long run. So the basic pieces, pretty simple. These are self-centering drill fixtures. You can get these off Amazon. I got these at Harbor Freight. They were about $8 a piece there. Yes, I trash on Harbor Freight quite a bit. They make a lot of crap. They make some okay tools. You got to pick through everything and know what you're buying. And in this case, all I needed was a simple piece of extrusion. It's pretty hard to screw that up. So then this is 1/2 inch by 1.5 inch bar stock, foot long. I ordered these from McMaster Car that were cut this way already. And then I ordered this set of bushings. So this is a pretty conventional pressed in bushing. It's mated up to these. Their fit is precision ground. There is no room for error. A speck of dirt and they would not go together. And the idea, these are called slip fixed renewable bushings. They have a couple uses in the tooling world. One is in a fixture where it gets a lot of use. These drill holes would eventually get blown out, and rather than make a new tool completely, you just pull it out, drop in a new one of these, and you're good to go. And the other use is it allows you to pick different size holes and step your way up, all while the fixture is clamped in place and the whole position is maintained super accurately. All I did was came in, I set these in here so that the just barely clears the tubes. This position isn't super important other than being fairly in rig. And then I marked out the locations for the bar stock where they interfaced, marked it with a Sharpie pen. I used my 2-inch angle grinder to get me some clean metal on both the mating surfaces and used some high sol, and I squeezed them together. So now I was going to get a pilot of like 128, 156, somewhere in there, because that's how I did these holes in the wing spar originally, and it kept the drill from walking. I'm counting on this thing not moving in this case. And the reason was I could get a pilot that was appropriately sized, but it wasn't going to get here till the middle of June. And so I got what they had. So I got one for 19/64, that's this one. And I got one that's 5/16 on size. And the only hole I'm actually going to be using it for is the 19/64. So you might wonder, why did I bother getting the 5/16? And the answer is because that's how you have to position it here. For example, this is my 19/64 drill bit, and if I test it in here, you can see how much room for error there is. So the only way to get this located accurately would be to use that's my 5/16, and then a 5/16 drill bit. And you can see if I drop this through here, into there, there it goes. That allowed me to get everything clamped in position, glued. And then when I came back today, I also I double checked everything, nothing had floated around, and then clamped it down tight. I was anticipating it would also tend to cause it to move a little bit, and I got pretty lucky and it went right in. So now I know for a fact that if I ran a 5/16 full-size drill right through here, it would not cut any metal on this spark carry through. But I'm not going to drill that here. I'm going to now drop back to my 19/64, and this fits super precisely in the drill bushing, and then it still is clearanced. It's not going to actually touch that spark carry through hole, and that is the basis for this tool design. If I try this on the other side, just so you can see I'm not full of crap. 5/16. And this one just slips in here, just barely. That's all I need. So now I know that the fixture in the center of that hole and the bore of that hole is perfectly concentric to the one of the spark carry through. So then pull it out, put in 19/64, use my 19/64 drill and blow that through. And again, it's going to be perfectly in the center of this hole and drill the hole in the top of the spar. And then I'm going to pull that out and use my 5/16 reamer through the top hole, and I will lift it up just a little bit. I could end up pulling the wing before I do that. I haven't really decided. In case you're wondering why I don't run a 5/16 reamer through the 5/16 drill bushing, it's because a reamer is actually out at 4+ decimal places is slightly larger than 0.31250. So there's a little spring back in the way it works. So short version is a 5/16 reamer doesn't fit through a 5/16 bushing. Drill bits, on the other hand, tend to run undersize, and I kind of have a funny story about that. So just because a drill was 5/16 diameter, in practice, in a good rigid machine and well fixtured, the hole turns out to be a tiny bit smaller than the diameter of the drill bit, especially one that's had some miles on it, and this one really hasn't. So the funny story is, when I went to go make these, like I said, I ordered these from McMaster Carr, and I wasn't sure I was going to be able to get the holes to the right size that I could press these bushings in here. So I also got a piece of nylon, nylon 66 or something like that, glass-filled nylon that was the exact same size as this, and I also bored, this is a 3/4 inch diameter hole on the outside. And of course, when you get down to it, they want you to have a certain amount of press fit, and so I was worried about it being undersized, and I was going to have to find a way to press that in. And I thought, well, I could press that into nylon a lot easier than I could press it into aluminum. Well, I set up with my super old Craftsman drill press over there, and it has quite a bit of run out, worn out tool, kind of chattered a little bit on the inside. So I just dropped the bushing into the hole, and it looked like it was going to be barely a press fit. I could probably just give it a little whack with a dead blow hammer and it was going to be fine. And I didn't know that till I'd walked over to my local mechanic, and I was waiting while he was on the phone. I played with those bushings, and they actually would have slipped right into the nylon and the aluminum. Almost. They didn't quite fit flush, and so what I figured I was going to do was scuff up the outside of the bushing and the inside of the hole, clean them up real well, and use some Hysol and locate them. Well, I did that at home in my garage, and I only got them part way in, and there was no way I could press those in there with a dead blow hammer, let alone vice jaws that I kind of padded a little bit. So I had Hysol in it. I ran back over here to the airport to my mechanic, and he happened to be there, and he's willing to let me use his arbor press. So we pressed these in, they fit flush, and the crisis was averted. So little intermediate step right here, put the wings back on. I'm just starting to do so they're nothing like in rig, and I thought I'd film this part so you can see kind of how this goes. I realized that my string across here for setting the wing sweep was going to be an issue with the clamps. I flipped these around to the back side. I verified that the drill bit still slipped through the spark carry through and on both sides, so that's all good. And then this wing was sitting here on two of these tall sawhorses, so all I had to do was lift this end and slide it inboard, plug in the bolt Check that the fuselage is still level. I suspect it got bumped a little bit, taking the wings off. Anyway, the right wing, I was going to wait around and find somebody to help me do it. It was sitting on these sawhorses right here, upside down, so I could verify those witness holes on the scribe lines. But I tend to not wait around very long. So I grabbed the sawhorse that was on the inner end here once that wing was up. And it's, of course, still supported out on the end, so I'm not worried about the airplane falling over. Moved it out there, checked it for level, that it wasn't rocking, and that I just picked up that wing. These wings are super light. It's almost amazing that they have the strength they do. Set it on that end, plugged it on here, got that bolt started. I clearly need to ream that hole out, but that can wait because I know it's going to at least stay concentric. And should be super easy to see that the wing sweep on this right wing is completely destroyed, and I'll need to move that wingtip again, sweep forward. You can also see, because this hole hasn't moved, it's supposed to be, the hole is about 3/4 of an inch in, so got a lot of work to do. So I will sweep that wing forward, get this pretty close, and then before I bother leveling the fuselage, I'm going to get those lift struts back on, which I also think I can do by myself. We'll see. Stressful part is done. I drilled this hole to the 1964s. Actually started with this one over here. This fixture is still in place. I just popped one clamp. I had to get the drill bushing out of here. It went well. Could probably make some design improvements, but for what I did and for how long I spent sweating this, huge relief. So I came out here this morning, set about rigging the wing sweep again. Used the same piece of extrusion I had last time. I brought other piece of extrusion, a whole bunch of other ideas. Pretty much everything I tried was going to get in the way of this string, which sets our distance here. It took me about 10 tries back and forth. Every time I would move one wingtip just a little bit, of course it affected the other side that I thought was perfect. In the end, I got it locked in, nothing moved. My drill bit has a little bit of run out, not sure where that came from, but the bushings ran true, and the lines, both of them, they come out just a tiny bit behind this line I scribed on here a long time ago. That was just a practice anyway. It wasn't going to be where the hole went, but they're symmetrical. My sweep is good. My dihedral is still at 1 degree, and my washout, as I had hoped and predicted, the lift strut attachments, because they hadn't moved, really the only thing I was going to be fighting was the wing sweep. But of course, like I pointed out before, any one of these dimensions, when you change them, it could affect the other one. So I, at least twice, I went back and measured dihedral and washout, and they were right on the money. So was out of excuses, time to grab the drill. So now, so I already popped this fixture off. That one's about to come off. I will probably open the wing up a little bit and blow this hole through with the reamer, and then I will be able to drop in the pin, which I hope I have with me, I think I do, which goes here, and then I can set about worrying about the lift strut attached fittings. The manual does have you just take them off as they are right now, clamped, flip them over on the bench and start drilling. I really want to have a couple holes in here. I got to think that one through, I guess. I'll go back to the manual, and based on the fact that they hadn't moved and the witness holes were right over my scribe lines, still pretty happy with that, so maybe they're right. But big step, and I didn't screw up my wing, so happy day. And there it is, officially a zero sweep wing. These pins drop right in. They don't blow out the bottom yet, so I'm about to cure that. You go to the rear holes, blow that through. You pretty much have to do it with the 5/16 on-sides drill. They tell you to use one with a stubby bit of cutting edge so that it doesn't open up the hole up in the top. So I'll have to see if I have one of those. All right, well, the deed is done. These forward pins are drilled, all the holes are drilled all the way through, both wings. They are freestanding, not being supported. Started by checking that the fuselage was still rig square to the world. It is 1 degree, 1 degree. Still got a 1/2 inch washout, and my sweep is 0. So now, like I said, I would like to drill a pair of holes in each of these lift strut attached fittings. Get a cleco in them just for peace of mind. And I also didn't bring that drill bit, so but I also need to work out the steel doublers which go on top and inside, top and bottom, for all 4 tubes. Of course, I'll need to deburr my doublers. They were started by the previous builder, but I'll need to finish fabricating those and read up on the manual on how to go about installing those. And I think I'm still going to have to do a little bit of, I got some clearance here, but I don't know that it's enough for both those doublers inside. Anyway, again, these come out bang on, holes are reamed out, and moving on.